In this video, we're going to talk about acyl chlorides. We'll go through what an acyl chloride is and the reactions of acyl chlorides, and then go through some MCQ style questions. Acyl chlorides can be made by reacting thionyl chloride with a carboxylic acid. Thionyl chloride is SOCl2, and if we take ethanoic acid here and we react it with the thionyl chloride, we will make the acyl chloride, which is where the Cl has replaced the OH. Okay, and then you get SO2 and HCl. Really important to note that this is a very common question just to finish this equation. Okay, so if, for example, in your molecule you had 2 carboxylic acids, you would need 2 moles of the SOCl2, and you would create 2 moles of the SO2 and 2 moles of the HCl. I've seen a question where it puts 3 carboxylic acids in one molecule, so again you'd need 3, 3 and 3 for the SOCl2, SO2 and HCl. So just be aware of that. So the next point is, how do we name them? So we name them with the ending oil chloride. And all we do is we take the stem, which is the length of carbon chain, which is 2, and then we put oil chloride on the end. So 2 carbons, ethan, and then oil chloride, so ethanoyl chloride. And that's how you name your acyl chlorides. Now remember as well that the acyl chloride is a high priority compared to most groups. So if you're prioritizing numbering and things like that, the acyl chloride is normally number 1. Let's go through the first type of reaction that acyl chlorides do. Now, acyl chlorides are more reactive than their carboxylic acid that they're made from, and therefore they react at lower temperatures. So when you're reacting with an acyl chloride, you don't need to give a temperature generally, because it's done at room temperature and pressure. Now, because of this higher reactivity, it can do a lot of reactions that carboxylic acids can do, including esterification. So let's go through an example. The example we're going to go through is 2-methyl propanoyl chloride. So if I take and do its skeletal formula here, okay, so there is your 2-methyl, and there's your acyl chloride. So we have our acyl chloride. This is 2-methyl propanoyl chloride. Remember, this is number 1, this is number 2. Really useful just to remember your dipoles. Here is a delta positive, here's a delta negative. Okay, this is also delta negative, but we're going to leave that for now. And then we react that with our alcohol. So our alcohol is going to be methanol. And I'm going to deliberately draw the H in red, and you can see that there. So we've now got our alcohol plus our acyl chloride, and they're going to react. Now the reason I've put that in red is to show you that the H and the Cl, they will react with each other and they'll disappear. So literally the lone pair of electrons, okay, that is on the oxygen will come in and bond with this carbon. And this oxygen will then bond with the carbon to make the ester. So if we draw this, that basically means we've got our ester, and there is our ester. Remember, this O here is this O here, and it's joined onto that carbon there. And then that also makes HCl. And the really important thing here to note is when you're doing esterification, you're going to create HCl instead of H2O. Normally you do esterification and it's H2O, but this time it's HCl. So what type of reaction is this? So the important point is, we'll go back to our exam tip, a condensation reaction is a reaction where 2 molecules combine and you kick out a small molecule, often water. Now, often water, not always water. So if we look here, this is a small molecule, it is kicked out. So this reaction is also from 2 molecules coming together. So this reaction is condensation. And that means that whenever you do esterification using an alcohol and a carboxylic acid, that is condensation, but also if you use an acyl chloride and an alcohol, it is also condensation. That can often be in multiple choice questions. We're now going to talk about the reaction of an acyl chloride and esterification with phenol. Now there's an important difference to note, and the difference is that acyl chlorides react with phenol to form esters. So they do react with phenol to form esters, but carboxylic acids do not react with phenol to make esters. So if you have a molecule that has an acyl chloride in it and a carboxylic acid, and you react it with phenol, you're only going to react the acyl chloride part. So let's look at a type of reaction for this. So we've got acyl chloride, ethanol chloride, then we have phenol, and the H and the Cl are highlighted because they react together, and this forms a condensation reaction as a result. Let's look at the full equation. The full equation is creating this ester here, and you've got the ester group here. And you can see that this is a phenyl. This comes from the essentially alcohol part. It's not an alcohol functional group, it's a phenol, but it includes that OH. So if you're naming this, this would be phenyl, and then you have the stem chain, which is from the carboxylic acid or the acyl chloride, which is ethan, O8. And you also make this HCl. So here's your name, phenyl ethanoate. We're now going to synthesize amides. And those synthesizing of amides are done through acyl chlorides. So acyl chlorides react with amines to create that amide. So let's do the simplest example that you can think of in terms of drawing acyl chlorides and amines. So we need a really simple amine and a simple acyl chloride. So here is our acyl chloride. And again, we highlight our chlorine and Cl because it leaves. And then we add that to the simplest amine that we can come up with. The simplest amine we can come up with is N. I'm going to draw the H in red because it's one of those H's reacts with this chlorine. And that's our simplest amine we can think of. Now that amine is then going to react, and it reacts because this lone pair of electrons goes into this delta positive center, delta negative. This goes in there and bonds in. And you're going to create your amide. So what does the amide actually look like? So the amide is the acyl chloride, but we have an NH2 coming off. Okay, so there's our NH2 coming off. So this is our amide, all of it there. So if we were ringing the whole functional group, that would be it. Now, on top of that, we can name it. So if we look here, we've got 3 carbons. Because we've got 3 carbons, it's prop, and it's an amide. So it's called propana, and then you finish it with amide. So it's propanamide. And that's how you name it. Just do the chain, that's your starter, that's your stem, and then just put amide on the end. Now if we just finish off the reaction, we have that, and then that will create our HCl. Now, a little bit of a complication here. If this is in a 1-to-1 ratio, there won't be a lot of ammonias around, okay, and you'll just get this reaction happening. But let's just say your ammonia is in excess. So if the NH3 is in excess, because sometimes in questions it is, that means that the HCl, that can react, and it can react with the excess NH3. And if HCl reacts with the excess, that's only if the NH3 is in excess. You can also have another product formed, which is NH4Cl. So you may see in past exam papers and things like that, this reaction happening. And you can see that if they say the ammonia is in excess, instead of the HCl being a product, you would have NH4Cl as a product, because there's so much of this ammonia around that it reacts with the HCl and then turns into NH4Cl. But that is only if the ammonia is in excess. If it's not, you needn't worry about it. Okay, just if it is in excess. Now we know how to make a primary amide, where we have the NH2 bonded to what was left of the acyl chloride. We now have to go on to knowing what a secondary amide is. Now, a secondary amide just replaces one of the H's with an R group. So here we've put R2 instead of one of the H's coming off. A tertiary means two R groups. So we've got R1 and R2 there. So let's put this to the side, and then let's talk about some different examples and see how we can draw those from their names. So we have ethanamide. Therefore, remember how to name them. You just put amide at the end, and then we have the parent or stem chain, the longest chain, which in this case is too long. So we need to draw a model or a structure that has two carbons in it. It has that double bond O, and then it has our amide. Okay, so that is our primary amide, ethanamide. Now we're going to do our secondary amide, which is N-methyl ethanamide. Now we're just practicing here how to use these amine writing nomenclature. So do not worry too much about using it with amides, but we thought it'd be good to go over it with you because it's not too different from amines. Now N-methyl ethanamide, well that's telling you that the methyl is on the nitrogen. It's telling you that the chain is too long and it's an amide. So if that is the case, we still got eth, and then we go down to our nitrogen. Now it tells us on the nitrogen is a methyl. So I'm going to stick a methyl on that nitrogen, and then the other one's going to be a hydrogen. So that is N-methyl ethanamide. We then go to the tertiary amides, N-N-dimethyl ethanamide. So that's telling you have two methyls, both on the nitrogens. There's two N's saying one of the methyls on that end, one of the methyls on that end. There was only one N in the entire thing. So let's try and draw it. So if we try and draw it, we've got the ethan again. There's our N. Okay. And then we're going to put our two methyls on. 1, 2. This is N-N-dimethyl ethanamide, N-methyl ethanamide, so one methyl, and then we've got ethanamide. So they're all variations on a theme, and they're all primary, secondary, and tertiary amides. We now know the difference between primary, secondary, and tertiary amides, and we've gone over how to make a primary amide with ammonia and an acyl chloride. But let's talk about making a secondary amide, again through an acyl chloride, but using this time a primary amine. That will then turn it into a secondary amide. So let's make some space. And then what we can do, and I thought it would be really useful to go through this in structural formulas to give you a slightly different look at it. So we're going to pick an acyl chloride. So let's just go to this acyl chloride. Okay. Now again, I want you to think, what acyl chloride is that? What is the name of that? Well, this is the acyl chloride group you're going to see if you are doing it in structural formula, and that is how it's written in structural formula. And look at the 3 carbon chains. This is propanoyl chloride. We're then going to add that to a primary amine. So the primary amine, the most simplest one we can think about, is methanamine. So that methanamine would then be written like this. And there's our methanamine. So be aware that you will have to do this sometimes in a formula which might not feel comfortable for you. So if they present this in front of you, this is structural formula, and you would have to use it. If that is the case, I would then go from this to say, look, this nitrogen, as I pointed out before, this lone pair comes in to this carbon right here. So this carbon right here, and will bond. If we then make it bond, we can do CH3, CH2, CO, okay, and then we've got the N, okay, and it's NH, and that CH3 is on the NH. And that looks really, really horrible written out like this. So I'm not only am I going to write it out like this, I'm going to write it out in skeletal formula as well. So this C here is this C here. And the O is the same, so look for the comparison. The O is the same, the CO is the same. All I've done is bonded that N onto that C, and that has a CH3 on it. That's that CH3 you've got right here. Okay, and we've made ourselves a secondary amine. But let's have a look at this, and let's draw this out in skeletal formula a little bit differently so it makes a bit more sense. So in skeletal formula, we are going to go, there is your propanol chloride, same as you've got up here. And then we have our and there's your NH2. Let's make that clear. There's your NH2. And then from that point, this is going to turn into our amide here. So if we look at our amide here, we're going to draw it out 3 carbons first. And there we go. And then we're on the N here. Then we draw the H, which is there. There's our CH3. And we have a secondary amide. See, we have one R group there, okay? And so it's a secondary amide. So we've drawn these both in structural formula across the top. We've drawn them in skeletal formula across the bottom. Now what I haven't included, which I will just finish off by including, is the fact that, remember, when this reacts, it's a condensation reaction. So the Cl leaves and one of the H's leave, and so therefore we have plus HCl here. And of course, underneath here, we'll also have plus HCl. So we have structural formula written out if you need to do it, and then the skeletal formula written out, and that is how you synthesize a secondary amide from an acyl chloride and a primary amine. We're now going to do our last reaction of acyl chlorides in this video, which is acyl chlorides and water. Acyl chlorides are made from carboxylic acids, and they can be returned back to carboxylic acids by just adding water. So they have to be kept anhydrous without water, otherwise you won't be able to react them because they'll turn straight back into the carboxylic acid. So if you ever see water appear at any point during an acyl chloride reaction, it's a really bad thing because it ruins the reaction and breaks down the acyl chloride into that acid. So let's look at an example. So we've got an acyl chloride here, again ethanol chloride. We add our water. You add your water, it turns straight back into the carboxylic acid, and it has HCl that comes out as a result. Okay, now this is not called, you would think, condensation. Normally this is called hydrolysis because you are adding water. So this is a hydrolysis reaction. It's really important that you know that. But for now, let's start talking about some MCQs. So acyl chlorides come up a lot in MCQs. So which one of the following is not a condensation reaction? So remember our rules on condensation reactions. It's when 2 molecules come together to form a small molecule such as water, or in acyl chlorides context, it is HCl. Let's move this over to the side and let's look at this again. So it's condensation we're looking for. Remember that definition we've just gone over. And you can see, let's start to identify these 2 different parts. So we've got an acyl chloride plus an alcohol. Acyl chloride plus an alcohol reacts to form an ester. Reacts to form an ester and HCl. Small molecule, such as HCl or water, which is produced from two molecules here. So again, that would mean that most definitely that number 1 and A is going to be a condensation. So I'm going to label that as condensation, okay? We then go to the next one, which is a carboxylic acid plus C6H5OH. Now you have to recognise the C6H5OH, okay? If you see that anywhere, it's going to be phenol, okay? It's their shortened way of putting phenol in, and it's to confuse you. You see the C6H5OH, it's phenol. So this is phenol plus a carboxylic acid. Now go back. Does a phenol and a carboxylic acid react? Well, the answer is it doesn't react in the first place. So essentially, on that one, there is no reaction. Okay, so there's no reaction at all on that one. So we know that's not a condensation reaction because it's not a reaction in the first place, but let's carry on and do the rest just in case. So if we look at this one, we've got an acyl chloride and we've got an amine, we've got ammonia. Acyl chloride and ammonia will make a primary amide, and that will also produce hydrochloric acid as a result. So that most definitely is going to be a condensation because it produces that HCl. And go down to the bottom one, CH3COCl. So again, it is an acyl chloride, this time with a primary amine. And again, those will react to create a secondary amide, okay, and HCl. So if that is the case, that is also going to be condensation because you've created that HCl. So our answer for this is which one is not a condensation reaction, and the answer is most definitely going to be B. And the reason the answer is B is because no reaction takes place in the first place, so not only is it not a condensation reaction, but it's actually not a reaction at all. So let's do our next MCQ exam style question. Remember, you can do these before I explain the answer. So let's have a look. Which one of the following reactions would give the highest pH? So you've got here carboxylic acid plus an alcohol. You've got an acyl chloride plus phenol, and you've got an acyl chloride plus water, and then you've got an acyl chloride plus a primary amine. So let's first of all get some space. And then let's look at the products of each of those. So what you should be doing right now is thinking, what is the product? Pause the video, do the products. Okay, so the first product is an ester. So we've got an ester here plus H2O. Next one is going to be another ester, but we make HCl. Next one is a carboxylic acid plus HCl. And then the last one is this secondary amide plus HCl. So the first thing is you have to know the products in order to know what the pH would be. So let's have a look at that, shall we? So water has a pH around about 7. And then we go for the next one, which is HCl. HCl is a strong acid, so pH 1 to 2, roughly. And then we've got HCl in the next one as well. You can ignore the weak acid here because the HCl is a stronger acid, so therefore pH 1 to 2. And then we've got the last one that also creates hydrochloric acid, so pH 1 to 2. So basically all of these are pH 1 to 2, and this is pH 7. And the question, as we've highlighted here, says which of the following reactions would give the highest pH? Well, the highest pH that would be given is pH 7 because all of the other reactions create HCl and give that lower pH. Now these questions are really, really common. Because they're really, really common, I really recommend that you know all of these reactions and research all these reactions and make sure you commit them to memory. Now, let's do the final MCQ question of this video. Now, which compound is a secondary amide? So we talked about acyl chlorides, but we talked about how to create secondary amides. So let's have a look. And this, again, common question. Have seen it many times before. Okay, so a good one to practice. So here is your 4 compounds. And all you have to do is decide which one is a secondary amide. So again, which one do you think is a secondary amide. So let's go through each one in turn. First of all, let's decide which ones are amide. If you look here, the amide must have the nitrogen of the NH2 or the NHR or NHR1R2 must be bonded to this carbon where the carbonyl is. It's not. So this is actually a ketone and an amine. It is not an amide. So that is not an amide, so it's not the answer. We then go to B. This is an amide because the N is bonded to this carbon. Okay. And there is one R group coming down from it. Well, if it's a secondary amide, you need one R group. So I reckon this is my secondary amide because I've got one R group coming off it and one H. If it was primary, there would be two H's. If it was tertiary, it would be two R groups coming off. But we've got one R group, so I reckon that's the secondary amide. But let's do the rest anyway. Look at this one. This is an amide because the N is bonded to this carbon as part of the carbonyl. This is primary because we've got two H's. And then we look at this one. This is actually a carboxylic acid and is not an amide. So D, C, and A are wrong. And the answer for this is B. That is the secondary amide.